Okay, here's 37. The interior angle of a regular octagon. Okay, so once again, there's a formula for this. The interior angle measure. So we got to figure out what all of the measures are. So n minus 2 times 180. Okay, that gives you the angle sum. That's the interior angle sum. And if you divide that by the number of sides, that gives you the interior angle measure. Okay, so an octagon has 8 sides. 8 minus 2 times 180 divided by 8. Okay, so that should give us an interior angle measure of 135 degrees for an octagon. Okay, the area of a regular octagon with a radius of 6. Okay, so normally this is a regular polygon, so 1/2 of apothem times perimeter. Right, and perimeter is known as the number of sides times the side length, so 1/2 of ANS. And we know it has a radius of 6. Well, that's even harder. Well, there's another formula that I showed you guys that is somewhere. Let me see if I can remember it. I don't have it in front of me right now. N times 1/2 of r squared times the sine of your central angle. Okay, so let's see. Let me draw the octagon on here so we can talk about this, why we're using this formula. Okay, so here's your octagon. We know the radius is 6, which means all of the radiuses are 6, right? So we have ourselves a triangle right here. Okay, and if we would do this over and over and over, we could have how many triangles? Well, we could have 8 triangles. That's why we're using the number 8. So that's where n comes in, 8 triangles. Okay, and then this formula is for the as a trig area formula if you know the central angle and the 2 sides around it. And in this case, we do. So our central angle is simply, well, I don't want to say simply, but 360 divided by 8. Okay, 360 divided by 8 gives us a central angle of 45 degrees. So that goes in here, 45 degrees, sine of 45. And we know the radius is 6. Okay, so that's why we're using this formula, because we know the radius. That's the best information that we have. Okay, so 8 times 1/2 times 6 squared times the sine, make sure we're in the degree mode, sine of 45 gives me 101.8. 0.823, in fact. Okay, the area of a 15-gon with a side length of 8 inches. So there's a formula that we talked about in class for area of a regular polygon if we know the number of sides. And that was n times s squared over 4 tangents of theta. Well, theta is your trig angle. Right? This is the trig angle, which is 180 divided by the number of sides. Okay, and it's all a derivation of 1/2 ANS, right? Those Satan problems that we did in class. So we know that there are 15 sides, so n is 15. The side length is 8, so that's 8 squared, right? We're going to square 8. And the angle 180 divided by 15 is 12 degrees, so tangent of 12 degrees. So we're going to put all this in our calculator. All right, we have 15 times 8 squared divided by 4 times the tangent of 12. And that gives me 1129.111 square inches, right? Of course, inches squared. Let's use the correct units here for area. Okay, the area of the parallelogram. So here we have our areas, right? You're going to have these formulas. The area of a parallelogram is simply base times height. So if we have a base of 11 and a height of 6, right? We know it's the height because it's perpendicular. Then we have an area of 66 square units. Okay, base times height for parallelogram. Triangles. So notice what we have here. In this triangle, we have 3 sides. Okay, and during the unit on triangles, if you have 3 sides, we're going to use Heron's formula. Don't worry, you'll have that on your test. We'll have Heron's formula. So the first part of Heron's formula is finding the semi-perimeter. So we do that by adding your three sides together. Sorry, that's not 7. I said 3, 7. And dividing it by 2, right? Semi-perimeter. That's half of the perimeter. So we find the whole perimeter, which is 15.7, and divide it by 2 and get a semi-perimeter of 7.85. So this is how the Heron's formula works. It's the square root of a big old thing, so 7.85. And then you take your semi-perimeter and you subtract each of your side lengths, so minus 7. 7.85 minus 3.8. 7.85 minus 4.9, right? So we subtract each of the side lengths from your semi-perimeter, and then you multiply them together, and then you take the square roots. So let me do that in my calculator and see what we get. 8.929, right? When I rounded through decimals, 8.929. So make sure you're using the decimals, right? Make sure you have decimals and subtraction in your problem. Be careful when you're putting it in. Okay, if the area of the trapezoid is 39, then what is x? Well, the trapezoid formula is area equals 1/2 of the sum of the bases, so x plus 9 times the height of 6. Okay, so you're going to have these formulas. You just need to use them correctly. So multiply by 2, right, to get rid of the 1/2. 39 times 2 is 78. And here we're going to distribute 6x plus 54. So we're going to subtract 54 from 78. Right, and then divide both sides by 6. So I get an x value of 4. Okay, the area of the rectangle. So if I want to find the area of the rectangle, I'm going to need to know what is the height, and I'm going to need to know what is the base length, right? Base times height. So I have 3 things to find, and I'm going to find them all using trig. Okay, so this is a trig problem, and it's very handy to know trig. Okay, so this is my hypotenuse. Start off with h. H is the opposite side to my angle. This is my hypotenuse. So I'm going to use the sine. The sine of 56.3 equals opposite h over hypotenuse 3.6. Okay, and that's how I'm going to find the height. Now, x is my adjacent side. Adjacent uses cosine. So the cosine of 56.3 equals x over 3.6. And then over here, right, y is the opposite side. So to find y, I'm also going to use the sine. The sine of 59 equals y over 5.8. Okay, so I'm going to do these 3 calculations, and I will come back with the answers. Okay, so my height is 2.995, right? That's what I got when I did 3.6 times the sine of 56.3, right? Denominator 3.6 times sine of 56. I did 3.6 times the cosine and got 1.997, and then I did 5.8 times the sine of 59 and got 4.972. So if I do 2.995, which is basically 3, times 1.997 plus 4.972. Okay, we'll do it exactly and see what we get. That is 20.866 as the area. So maybe your answer key says 21. That is some pretty good rounding, but 20.866 is going to be the exact area for that rectangle. Okay, so these are all about polygons and the moment quadrilaterals. Right, so finding the areas, you're going to have all the formulas you need to find the areas.